Good morning. This is your Stat Sensei, Mr. Spensei, and this is assignment here that we're going to go over is primarily focused on the inverse norm function of the calculator. And remember, when we are working with the inverse norm, they're either giving us an area, a percent, or probability. That's how we know we're using the inverse norm. So the annual salaries of employees in a company are normally distributed. We needed to know that so that we could use the inverse norm or the norm CDF, as the case may be. An employee earns in the top 3% of the salaries. What is the Z score? Well, that's important information. So, first off, they're asking for a Z score. All Z scores have a mean equal to 0 and a standard deviation of 1 when we're working with the normal. So, in the top 3%, so anytime they give me a percent, I put an X. And they're like, oh, top, that's above it. So that's going to be above my X. So that's going to be 3 over 100. So 0.03. So now I can draw my picture. And my picture is going to look something like this. Mean is 0 because that's we're working with a Z score. And this area right here happens to be 0.03 because that's a 3 divided by 100. Anytime they give you a percent, divide it by 100. All right, so I'm going to go inverse norm. That's where I'm going to go on the calculator. And the reason I'm going to do that is because they gave me a percent. If they give me an area, percent of probability, if they give me an app, I go to inverse norm. So let's see what it asks for. Second vars, inverse norm. And it asks for my area. Oh, well, we know our area is 0.03. We know the mean of all z-scores is 0 and the standard deviation is 1. We'll come back to this in just a moment. Let's get that information down. So area 0.03, mean 0, standard deviation 1. And remember, the way to remember the order is PMS, percent or probability, mean, standard deviation. Now, I need to look at this carefully because when I look at this, I shaded from the right-hand side. So I need to make sure that on my calculator, that I actually choose right-hand side. And there it is, 1.8807. See if I can cut down a little bit on the shadows. Not so much. Oh, well. All right. An employee earns in the lowest 10% of salaries. What is the associated Z score? Once again, I see that they give me a percent, so that lets me know I'm working with an inverse norm. And they said the lowest, when I draw an X, the low part would be down below here. So it's going to be the 10 over 100. All Z scores are centered at 0. And we're looking for the lowest 10% or 0.10. And we're looking for this X value. All right. So we're looking for that X, and this is our mean. So inverse norm, because that's where we're going on the calculator. It's going to ask us for our probability, which in this case is 0.10. It's going to ask for our mean of 0 and a standard deviation of 1. So second vars, inverse norm, mean area is 0.1, mean is 0, standard deviation of 1 because we're working with a z-score. And I notice I'm shading from the left. Second vars, I didn't change it. I did not do that correctly. Second vars, inverse norm. I'm shading from the left. I didn't press enter. All right. And I end up with a negative z-score, and it makes sense that it would be negative because I'm below 0. And numbers below 0 should be negative. So negative 1.2815. We'll box that answer. All right, so that's our z-score. The next one, what are the z-scores associated with the middle 90%, 97%? So once again, they gave us a percent, so that tells me I'm doing an inverse norm, but this one's going to look a little bit different. Once again, we're centered on 0. That's our mean, but we're looking for, I should have not put x's, I should have put z's because we're looking for z-scores. So these are my z-scores, and I need this shaded area right here to be 0.97. All right. So I'm looking for basically the center or the middle. So we're going to go inverse norm, just like we have. Calculator's still going to ask for the area or the percent, which is 0.97. It's going to ask for our mean. Well, it's a z-score, so it's 0, and our standard deviation is 1. So once again, we have our PMS. So let's go to the calculator and see what it says. Second vars, inverse norm, area, 0.97. That's the first thing we have. Mean, a 0, standard deviation of 1. Oh, we just want the center, so we're going to change that to center. And we end up getting two values. One's negative because it's below, and the other one's positive, and it's symmetric about 0. So we have the same numbers, except one's positive and one's negative. So we end up with negative 2.1, excuse me, negative 2.17009. And we end up with positive 2.17009. All right. So there's our answer for that. We'll go ahead and box that. And those are two z-scores. If your calculator only works from the left, here's what you're going to need to do. You're going to go second vars, inverse norm. And where it asks for the area, you can go parenthesis 1 minus 0.97, close parenthesis, divided by 2. And your calculator will be set to the left automatically. And there's my lower bound. And because it's symmetric about 0, you also know that there's going to be a positive and a negative value. All right. Our next problem. The daily energy consumption in kilowatt hours of households in a neighborhood is normally distributed with a mean of 32. So we have a mean of 32. I'm going to note that off to the side. And we also have a standard deviation of 4. That's the information they gave us. Pretty important. And they told us normal. What percentage of households will consume at least 36 kilowatts in a day? Well, if they ask you for an app, you're going to have to use a norm CDF. So this is going to be a norm CDF problem. If they give you the app, it's an inverse norm. If they ask for it, it's a norm CDF. So this is going to be a norm CDF. Our picture is going to look something like this. We know we have a mean of 32, a standard deviation of 4, but we're looking at 36. And it says at least, so we're looking for the probability that x is greater than 36. So we're looking for this area, and please remember this goes to positive infinity. So norm CDF, let's go and see what the calculator asked for. Second vars, norm CDF, it asked for a lower. Oh, well, what's the lower part? The lower part of our shading was 36. Then it asked for our upper. Our upper part is positive infinity. Then it asked for our mean. Our mean was 32, and our standard deviation was 4. So there's our LUMO, L-U, mean, lower, upper, mean, and our standard deviation. It looks kind of like an O. It's not, but that's what it looks kind of like. So our lower part of our shading happens to be 36. Upper part, 9 raised to the 99th, because that's the largest value our calculator will take. Mean, we said, was 32, and our standard deviation happened to be 4. mean of 32, standard deviation of 4. So we end up getting 0.1586. See if I can adjust the setting on my calculator just a little bit. Glasses on here. This is awfully dark. I don't know that that helped any. Oh well, it is what it is. But we ended up getting 0.1586. Here, we'll do that again. Second vars, norm CDF, 36, infinity, 32, 4. Then we get 0.1586. All right, next problem. 90% of households will consume less than how many? All right, anytime they give me a percent, I put an X. Now, the fact that they said 90%, I know this is going to be an inverse norm because they gave me the app. I put an X, will consume less. Oh, less, that's definitely below X. So this is going to be 90 over 100. That's going to go there. Now we have an actual mean of 32, standard deviation of 4. 90% is less. So we're starting here, but halfway is our mean, and that's 50%. So we're going to have to cross over till we get to here. Well, here we're not looking for a z-score. We're looking for an x value. And we're looking for that x value that is associated with 0.90. So inverse norm. We go to our calculator, second vars, inverse norm, and we're going to put in 0.90. It's going to ask for our mean, which was 32, and our standard deviation was 4. So let's go ahead and write that down. Inverse norm, 0.90, mean of 32, standard deviation of 4. This is our PMS, our percent, our mean, our standard deviation. And when we look at it, we started shading from the left. And we end up getting a value of about 37.126. All right. 37.1262 kilowatt hours. 37.1262 kWh. All right. 70% of households will consume more than how many? Okay, here's the key word, more. So I'm going to draw my X, and 70% is above that X. And remember, we're always dividing by 100. My picture is going to look something like this. We have a mean of 32, and we're shading from here because the 70 is above the X, but we have to cross halfway because halfway is 50%. So we're crossing all the way over, and this is going to be 0.70, or the 70 divided by 100. Because they gave me a percent, I'm going to go to inverse norm. This is going to be 0.70, mean of 32, standard deviation of 4. So there's our PMS. So second vars, inverse norm. Oops. Second vars, inverse norm. Area is 0.7, mean of 32, standard deviation of 4. And we're shading from the right to make sure right's highlighted. Press enter, and we end up with 29.9023. So 29.9023 kilowatt hours. All right. Okay, last problem. 75% of daily energy consumption falls within what interval? Centered about the mean. All right, so here we go. Interesting. First off, they gave us a percent, so that tells me I'm working with inverse norm. And our graph is still going to be centered on 32, but we're centered on it, so we're going to have some below 32 and some above 32. We're looking for a lower and an upper, and this area right here needs to be 0.75. So inverse norm, the very first thing it's going to ask for is our area, which is 0.75. Well, we know our mean is 32, and they told us our standard deviation is 4. So this is our lower, this is our PMS, our percent, our mean, our standard deviation. Second vars, inverse norm. Area is 0.75. Mean is 32. Standard deviation is 4. And we want to be centered. And we end up getting 27.39 on the lower side. And on the high side, we end up getting 36.601. So 27.3986, comma, 36.6013, 36.6013. And these are all kilowatt hours. There's my lower and there's my upper. All right. Appreciate you watching, and I hope to see you on the next one. Thank you.